Okay. We did some of them yesterday, so you look at the videos from yesterday, we did one or two of them there. Okay. A particle of mass m is suspended by a light inaccessible string of length 2d. 2d, and down here is 2d. The end A is fixed to, actually, and before I begin, I like to have a second diagram on hand, because I find if you only have one diagram, it comes so clustered that you actually haven't got a clue what you're doing. So there's going to be two separate diagrams. You're going to use the same diagram twice for this type of question. One of them's to resolve the forces, and the other one's to figure out angles. Okay, that usually happens every time. Now we'll start with this one. What does it say? The end A is fixed and particles released from rest when AB makes an angle A with a downward vertical. When B has risen again to a height so that AB makes an angle of 45 degrees with a downward vertical, its midpoint of the string comes into contact with a small horizontal peg, this thing here. If cos A equals a quarter, find in terms of D the speed of the particle at the moment that it touches the peg. Okay, let's start off with conservation of energy. Okay, so mgh1 plus a half mv1 squared equals mgh2 plus a half mv2 to be squared. I always tend to make the baseline, so that's height equals 0. Is everybody okay with that? H equals 0 right there. Now what I have to find out is, if I put a horizontal line this way, I have to find out what is the I need to find out the yellow height. Okay? In order to find out the yellow height, I need to find out the blue height. And then the whole thing, what's the whole thing together, the whole radius?
2D.
So, would everybody agree it's going to be mg? It's going to be 2d for the green. And then whatever the blue part is will give me the yellow part, how high I'm above the ground. Everybody cool with that? So let's find the blue part, is the key here. Okay? The blue part is an angle, it gives us the angle of cos A is, cos alpha is a quarter. So what that mean? That would mean adjacent is 1 over 4. Pythagoras' theorem will put the other side at root 15. 16, take away your 1. So cos A is a quarter, but sine alpha is root 15 over 4. Everybody cool with that? Opposite over, wait. No, I'm wrong. I'm wrong. I got it the wrong way around. It's actually the angle's up there, isn't it? So it's 1 over 4. It's actually I'm right. Yes, the same thing. The opposite is clearly bigger than the adjacent. Okay. So it's just making painful expressions at myself if the world right or wrong. Now guys, what we're going to say, that's 2D. Is everybody happy with this? Is everybody happy from A to B being 2D? So the blue part will be 2D cos alpha, which is 2D times a quarter, which is D over 2. Everybody happy with mg 2D minus D over 2, which is 3 over 2 mgd. Okay, does it have a starting off velocity? Does it start from rest, or is it given a starting off?
Rest.
Starts from rest, does it? So that's a half mv0 squared, yeah? So that doesn't count, so there's no starting off kinetic energy. Next thing I'm going to do is find out my end. So let's get rid of these ones here. So I have to find out this height here. How do I find that height there, guys? Once again, would you agree that it's the yellow, it's the 2D from the yellow, take away the blue length. It's my job to find the blue length, okay? So the blue length is, that'd be 45 degrees. That's the length 2D from here to here. Everybody happy with that being 2D? So what does that make the blue length?
2D over root 2.
Huh?
2D over root
2D over
2.
root 2. Okay? 2D over root 2. Now, mg 2D over root 2. Cos theta, yeah. What is 2D over root 2? Isn't it just root 2D? The root 2 can go to the top, can't it? Okay, so
Wouldn't it be mg 2d minus 2d over 2?
have to do the minus part, don't I? Yeah, you're right. I forgot to do that's the blue part, but it's meant to be the green part, take away the blue part to get the yellow part. So it's 2D minus root 2, the perfect averages. And we'll have a velocity, won't we? We'll have a half mv squared. Now what does it want me to prove? Wants the speed. So what's the target of the question? V on its own, yeah? Let's try this out. So 3 over 2 mgd, no bother, it's just 3 over 2 mgd equals 2 mgd. Take away root 2 mgd plus root 2 over 2 was not 2 over root 2. It was 2 divided by root 2, which is root 2d. Okay? Now, 2 ngd over the other side will make it minus a half mgd. The root 2 mgd will be positive then, so that'll be root 2 mgd equals a half mv squared. Multiply both sides by 2. 2 root 2 mgd minus mgd equals mv squared. The m's can get lost. The v can be the yeah, we got it. We have it locked up, guys. It's the square root of gd 2 root 2 take away 1. Only went for 10 marks. So that was a tough game. You can also put in decimals if you want to convert the G and all that out. Part 2. Find in terms of M the tension in the string when the particle reaches the same height as the peg. The particle reaches the same height as the peg. Where is the particle?
Just the end of the string.
Yeah. Alright, so here's what I think what happens. I'm going to get rid of this. It's a weird one. I'll show you now what's going to happen. Alright? So, this question is, I remember doing it before, and had I got it on the day, I would have struggled big time, okay? So it's a string, correct? So the string is here to here, and has a weight at the end. It hits here. What happens to this part of the string then? Stays there. What happens to the bottom part of the string? It lassos around like that, technically speaking, doesn't it? And it says that the particle which is located here has to be the same height, doesn't it? So it will have to reach up there, won't it? So how to go about even doing that is the very difficult part. Now we're going to start off with conservation of momentum, conservation of energy again. We're just going to try and do the first part and see how hard it hits the string. Does that make sense? How hard does it hit? Okay. Now, did I just rub out all that? What did I rub out here?
You need probably the speed.
Sorry?
The speed of it when it hits it. Just roll out.
give me a sec here, guys. I'm puzzled.
You see halfway through your own.
So guys, in part one, what we did was we took ourselves from here all the way down to here. We have to what happens is it was a length of 2D, but C is the midpoint. So now it's spinning around, if you will, in circular motion of length D as it bobs around this way. Okay? So what we're going to do next is we're going to have to set up, we're going to keep phi where it is, the last phi, and we're going to set up our equation again with the conservation of energy. Okay, so we go back to the top. Here we go. Now we're going to keep phi in the same way as last time. So phi is our starting off velocity this time, okay, not our end velocity. So it's still mgh. So what was the h we got from the last? We did this h already, didn't we? In the last question. What was it again? It was 2d
Minus root 2.
2d minus
D over 2.
root 2d. Root 2d.
That's for the second.
Yeah, that's how high we're above the ground for the second part, yeah? Because we're still this high above the ground, aren't we? And at the end we're going to be this high above the ground. At the same height as the peg C. Is that okay? Now what we also got to remember is we have corresponding angles here. So that angle is 45, but when I draw a line coming down from here, that's also 45. Okay? So that's 45 as well. Now our half mv squared is the same v squared we got in the last one, so it's a half mv squared. It's this velocity here. Okay? Now we're going to use a different letter we're going to have to use phi2. We'll use a different letter. I'm going to say that the speed when it's up here, I'm going to call it x, just to have a completely different letter. Okay? So completely different letter, we'll put that there at x. Okay? Don't know why it keeps doing that to me, but here we are. Okay? So half mv squared. Now what's the new height above ground? What happens to it when it's the same height as C? What can we say there? We need to find this height here, don't we? Oh, something else other than blue. Need to find this yellow height here. And what do we do with that yellow height? Take it away from
2D.
Take it away from 2D, and that will give us the height of the peg above ground. Colin?
Could you not use d to find for the angle? So you draw a line from where the ball is across to the...
Can I talk to you about that at the end? Because I'm just on a sort of a path here and I know where I'm going. Okay? So, the yellow one, if I draw a line like that and make a small triangle, this small triangle is of length d and angle of 45. Okay? So it's a d over root 2, isn't it? And then the height therefore will be mg 2d. 2d is the green. The yellow is d over root 2. Is that okay? And then plus a half mx squared. Right, so I'm going to grab all that, bring it down here. Okay? Because I sort of ran out of space, and I'll leave that. Jeez, nothing's working out for me at the moment. I'll leave that b over in the corner there. And I'll grab all this, and there we are. Okay, we're good. Now we have it all in alignment. We're going to work on this equation a little bit. I think the m's can go straight away, can't they? Okay. Then we have a, what's it, 2gd minus root 2 gd. What phi squared be? Square that back out again.
GD.
2 root 2 gd, take away gd. Then of course I have to half it. It's going to be all the lols.
GD minus GD over
Alright, everybody stop speaking. Okay, so I'm going to multiply everything by 2 because I don't want to deal with halves ever again. Alright, so see anything that's 2 and root 2? That's now going to be a 4 and a 2 root 2. Is that okay? and the other side is going to be
X squared.
x squared. That's just going to be v squared, wherever that is, and that's going to be 4d, 4gd, yeah? And what's the other part? Well, 4gd, and that's going to be 2d over root 2, which is minus root 2 g, yeah, root 2 gd. This is a great old question, this one. And what else do we have then? A half phi squared. I already did that up there, didn't I? It's just phi squared now because I cleared it with the 2's, so it's 2 root 2 gd minus another gd. Okay, January sales. Everything must go. The 4 GDs. Root 2 GD, take away GD equals x squared. We're correct, as it turns out.
How do you squared?
Huh?
And the squared?
That?
Yeah.
Just by. You don't.
You don't need to do that.
You don't even need to do it yet.
Use MV squared over.
Yeah, we're going to use mv squared in a second, right? So Alan's now leading me on to the one thing I haven't used yet. I need to find the tension, okay? Now, see this diagram? All the work I did on this diagram is now pretty much obsolete to me, okay? I'm now looking at, guys, I'm now looking at this this part here. I'm looking at this circle here, because that's where all my attention is. That circular motion there, if it actually would fit it properly, would be great, right? So I'm looking at this circular motion here, okay? Now what is the, we're looking for f equals m v squared over r. Okay, the radius is d, so we'll change that to a d to begin with. And what's the only thing holding it in place? Tension, isn't it? Tension going upwards, and then there's the tension is the only thing fighting it. It's the only force keeping it spinning. Is that right? Now, do I have to resolve mg? Does it have a weight? Is it massless or what is it? M. Okay. They, in the marking scheme, they just did T equals mv1. Here's what they did, and I'm going to tell you why I disagree with it. Okay, first time doing this one. What they did was they said that T goes upwards. Okay, and T is the only force that points towards the center of that circle. So therefore, T equals m. It's x squared, isn't it? Because that's its current speed. Mx squared over d. Alright. And then figured it out now. The tension, the weight acts downwards, okay? The weight would be inclusive if it was down here. But remember we said that it's level with the peg. And what happens when it's level with the peg? Mg is perpendicular to T. Therefore mg can't act on in the same direction as the centripetal force. Because they're perpendicular, there's no way I can resolve mg parallel to the tension. So that's why mg doesn't factor in the end answer.
You do it as if it did.
Huh?
You just do it as if it did.
No, because it'll be 0. It's impossible. Okay? So t equals x squared we have there, isn't it? It's m root 2 gd minus gd all over d. What happens to the d's? And then we're left with your tension equals mg root 2 take away 1. And that's the perfect answer.